Checkmate. Looks like he was under a lot of pressure. But that's just one type of pressure. What about gas pressure? All gases and liquids have a pressure. If I blow up a balloon, like this one, the air inside has the tendency to want to escape, because the pressure inside the balloon is greater than the pressure outside. A pioneer of the measurement of pressures was Evangelista Torricelli, who was credited with the invention of the device known as the barometer, used to measure atmospheric pressure.
Pump makers of Torricelli's time discovered that it was impossible to raise a column of water more than 10 meters above the ground. Torricelli wanted to reproduce this phenomenon, but not wanting to have to acquire a glass tube in excess of 10 meters long, he decided to use liquid mercury instead of water. Torricelli took a 1 meter long glass tube and filled it with mercury. He then submerged the open end of the tube in a bath of liquid mercury and righted the tube. He found that the liquid mercury fell down the tube to a height of 76 centimeters, leaving a complete vacuum at the top of the tube. He explained that gravity acted to pull the mercury out of the tube and back into the basin. However, the weight of the air around the device produced a force on the liquid in the tube. Equilibrium was reached when the pressure of the air, atmospheric pressure, exactly balanced the pressure due to gravity. This result convinced Torricelli that air had a weight, and he wrote, "We live submerged at the bottom of an ocean of elementary air, which is known by incontestable experiments to have weight," although his conclusion was disputed at the time. Many were not yet convinced, but after Blaise Pascal showed that at higher altitudes the measured atmospheric pressure was lower, popular opinion was eventually swayed. Torricelli kept track of the height of the column of mercury each day, and noticed that the height of the mercury in the tube depended on the day and the weather. This was because of variance in atmospheric pressure. Suppose we have conducted Torricelli's experiment and have found that the height of a column of mercury suspended due to atmospheric pressure is 76 centimeters. Then, given the density of mercury in water, how high could a column of water be suspended? We know that the pressure at the top of the tubes is equal to 0, but we also know that the pressure in both cases is given by pressure of mercury equals the density of mercury times standard gravity times the height of the column of mercury plus atmospheric pressure, and the pressure of water equals the density of water times standard gravity times the height of the column of water plus atmospheric pressure. Hence we can write that the density of mercury times standard gravity times the height of the column of mercury is equal to the density of water times standard gravity times the height of the column of water. Thus, cancelling the g's, we have that the height of the column of water is equal to the height of the column of mercury multiplied by the density of mercury divided by the density of water. Substituting values, we get that the height of the column of water equals 10 meters, which is what was observed by the pump makers.
The designers and builders of vacuum pumps can use this calculation to ensure that they construct functioning devices. Evangelista Torricelli was first educated by his uncle in Faenza, and then at college in Rome, where Torricelli went on to make several other great contributions to science. He succeeded Galileo as chair of mathematics at the University of Pisa by Galileo's own request, and is known for Torricelli's law, V equals the square root of 2gh, which gives the velocity at which water leaves a column through a hole punched a distance h from the top, and Gabriel's horn, sometimes called Torricelli's trumpet, a mathematical object which has finite volume but infinite surface area. Torricelli sure did make a terrific contribution to science. I'll show myself out.